So students, in the last class we have exactly stopped in this problem, right? So there was some problem in this one. You can see there are two, we have filled up this particular capacitor with three different dielectrics, K1, K2 and K3. So we can assume to be one capacitor, this we can assume to be another capacitor, this is we can assume to be the third capacitor. Then these two capacitors will be in series and the third will be in parallel with these two as shown in this diagram. Why? Because if I call it as 1, the positive of 1 and the positive of 3, they are connected. Positive of 1 and positive of 3, they are connected. Again, negative of 2 and negative of 3, negative of 2 and negative of 3, okay, they are joined. Negative of 2 and negative of 3, they are joined. Okay, so somewhere you can assume to be minus, and on the other side you can assume it to be plus, okay, because this is dielectric polar molecules, inside there will be negative positive, right? I have shown this one already. Anyway, so now if you calculate the capacitance of this first part, how much will it become? If I call it as C1, C1 will become how much? K1 epsilon naught, plate area A by 2 and separation D by 2. So this will become this. Similarly C2 will become K2 epsilon naught A by D. Like the way C1, similarly we get C2. In C3, the third part, K3 epsilon naught area is A by 2, separation is D. So this will come C3. Okay. Now 1 and 2 are connected in series. Therefore, the equivalent of 1 and 2, if I call 1 and 2 are in series, equivalent of 1 and 2, I'll call it as C12. This is in parallel with C3. So how much is C12? C12. That is C1 into C2 divided by C1 plus C2. So if you multiply K1, K2, epsilon of A by D, epsilon of A by D, C1 into C2 will get K1, K2, epsilon of A by D whole square divided by C1 plus C2, epsilon of A by D is common within bracket K1 plus K2. Okay, it's cancels, so you are left out with K1, K2 divided by K1 plus K2 into epsilon naught A divided by D. This is C12. So therefore, C equivalent will become how much? C3 plus C12. These two finally will be in parallel, so equivalent is sum of them. So that is why final equivalent is C3 plus C12. C3, this is C3. What is common between them? Epsilon A by D is common. So this will become K3 by 2 plus K1, K2 divided by K1 plus K2 into epsilon naught A divided by D. This will become the equivalent capacitance of this particular combination. Okay. Now we'll discuss a different problem. I'm wrapping it up quickly, so you can pause the video. Right? Now, capacitors with parallel plates. Let us discuss this particular problem. Let me consider n plates. N plates. All plates are same area and they are placed at equal separation. Well, how many plates are placed? N plates. They are connected like this. One is suppose connected to the positive terminal, the other is suppose connected to the negative terminal of the battery. So how many plates? 1, 2, 3, 4, N plates. Okay. A, area of each plate. D, separation between the plates. We have to find capacitance of the system. How much will be the capacitance of the system? How will you find? Okay, if we think this is positive, will go positive charge will be here, then this will become negative, this will become positive, this will become negative, this will become positive, this is negative, this is positive. This is not isolated plate, this has connection with the positive terminal of the battery, so from the battery positive charge will go and deposit there. This is connected to the negative terminal, so negative charge will go and deposit here. I can call like that. So on the inner surfaces, negative positive one capacitor, positive negative one capacitor, positive negative one capacitor. Okay, so 2 plate 1 capacitor, 3 plate 2 capacitor, 4 plate 3 capacitor, n plate n minus 1 capacitors. So total how many capacitors are here? Okay, right? N minus 1 capacitors. And how they are connected? They're all connected in series. They're all connected in series. So how much will become C equivalent? C equivalent will become, if capacitance of each plate is C, then this will become C divided by n minus 1. In series connection, if all capacitors are identical, then equivalent is nothing but capacitance divided by the number. Okay, in the last class you see my last class, I have had a detailed discussions on that. But what is C here now? Epsilon naught A divided by D. So this is the capacitance of this particular system. Okay, n minus 1 capacitors, all identical, they are all connected in series. Okay, similarly, if we consider 4 plates like this, 1, 2, 3, 4 plates like this. Okay, area of each plate, and this is the separation. Separation means separation between any 2 consecutive plates. This is separations. All are equally spaced. Now here, plate 1 and plate 4, 1 and 4, they are connected to the positive terminal of the battery, and plate 1 and 3 connected to the positive terminal, and 2 and 4 connected to the negative terminal, for example. Then what will be the capacitance of this system? What will be the capacitance of this system? Okay, so we can solve this particular problem in many different ways. Out of that, one shortcut I'll be showing. Okay, but be careful, these shortcuts are meant for NEET or ZEE mains. These are not meant for advanced. Okay, so those students who are preparing for advanced, for them there will be a different approach. Okay, that one I'll be showing you later. You have to do in detail, not in shortcuts, right? So if this is, since it is connected to the positive terminal, so on this particular plate there will be a positive charge. Charge on the outermost surface will become 0. On this side also, charge on the outermost surface will become 0. These discussions we had in redistribution of charge in conductors. Okay, in potential. You refer to that lectures. So this is positive. From here, positive will come here also. There will be positive charge. There will be positive charge. I am not concerned with the magnitude of charge out here, but I want to know which is positive and which is negative, so that we can make it out whether the capacitors, what capacitors will be finding, how they are connected, whether in parallel or in series. Okay, because capacitance, the magnitude of charge will not determine what is the capacitance. Capacitance will determine how much charge will come, but charge in the plates will not determine what is the capacitance. Clear? So in these situations, we already have some fixed system. So more charge does not mean more capacitance, because given dimensions are fixed. Okay, so that is negative. Positive, positive, this is negative, will come here negative, negative, negative. On this side, negative, 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 negative. From negative plate, we expect negative charge. Positive plate, we expect positive charge. We can think it that way. Now see, positive, negative, this will form one capacitor. Negative, positive, this will form the second capacitor. Positive, negative, this will form the third capacitor. Okay. If we have some kind of plate system, suppose there are 2 plates. Okay, on this particular plate charge is Q1, on that particular plate charge is Q2. Suppose on this particular plate charge is Q1. Okay, inner side charge is minus Q, then here charge will become plus Q, and here suppose charge is what? Okay, minus Q1. We suppose we have some this kind of distribution of charge. Then remember, the capacitance will be because of Capacitance will be calculated by the charge present on these particular surfaces. Okay, so let me not bring all these things here again, but here you need to understand positive negative one capacitor, negative positive another capacitor, positive negative another capacitor. Okay, so we have here three capacitors. Thing is how they are connected. See, three capacitors. So how to start with? Let us just start with one capacitor. Let me draw the capacitor 1. I don't know how they're connected. For example, whether they're connected in series or parallel. Once we become expert, then we'll say it directly. But this is the beginning. So let us start as if we do not know anything. This is capacitor 1. This is the positive plate of the capacitor. This is the negative plate of the capacitor. This surface represents the positive plate of the capacitor 1. This surface represents the negative plate of capacitor 1. This surface represents the negative plate of capacitor 2. This surface represents the positive plate of the capacitor 2. This particular surface represents the positive plate of capacitor 3. This particular surface represents the negative plate of capacitor 3. So negative plate of capacitor 1, negative plate of capacitor 2 and negative plate of capacitor 3, they are all connected. Positive plate of 1, positive plate of 2 and positive plate of 3, they are all connected. Or positive plate of 1, positive plate of 2 and positive plate of 3, they are all connected. Similarly, negative plate of 1, negative plate of 2 and negative plate of 3, they are all connected. Right? So finally their connection has turned out to be in parallel. So C equivalent will become 3 times C. C, 3C, because they are all identical, dimensions are same. So 3C will become how much? Epsilon naught A divided by D. This is the capacitance of this system. Okay. So now let me modify it a little bit. Let me consider the same 4 plate, 1, 2, 3, 4. But let me change the connection. Okay, let me call this is 1 and 4, let me join. Plate 2, let me connect it to the positive terminal. Plate 3, let me connect it to a negative terminal. What will happen to the capacitance in this particular situation? Okay, this is a positive plate, we expect something positive here. This is a negative plate, we expect something negative here directly. If this is positive, these two plates are isolated plates. They are not having any connection with an external source. This plate is having a connection with the external source. This plate is having a connection with the external source. But these two plates are not having any connection with the external source. So these two plates will be calling it as isolated plates. So net charge on these two plates will have to be equal to 0. That means on these two surfaces, equal and opposite amount of charges will get developed. So on this particular plate, what charge will get developed? Negative. Why? Because there is negative here. Oh, sorry, positive here. Big positive because negative will induce. And the same positive charge will come in deposit here. Equal amount of, I can say equal amount of negative and positive will get induced. Negative will stay, positive will flow and come deposit here. Because negative will attract positive and positive will repel positive. So positive will come and flow and deposit here. We can think in this particular line. So negative positive one capacitor, positive negative another capacitor, negative positive the third capacitor. So this is 1, this is 2, this is 3. So what will be the equivalent capacitance of this particular system? You see, what is the equivalent capacitance? Let me start with capacitor 1. Okay. There are many ways. There are many ways you can solve this problem, right? So this is one simple way you can solve it. So this is capacitor 1, this is the positive plate, this is the negative plate. We do not know what to do, we just started with positive plate. Now one thing, positive plate of 1 and positive plate of 2, they are together, they are joined to the positive terminal of the battery. So positive plate of 1 and positive plate of 2, they are what? Joined, and they are joined to the positive terminal of the battery. Clear? Similarly, negative plate of 2 and negative plate of 3 are joined. Again, negative plate of 1 is connected to the positive plate of 3. Negative plate of 1 is connected to the positive plate of 3. That's all. Now negative plate of 2. This is the negative plate of 2. Negative plate of 2 and negative plate of 3. They are joined together to the negative terminal. So negative plate of 3 and negative plate of 2, they are join to the negative terminal. So finally what we have got? C in series, C by 2, C in parallel. Equivalent is what? 3C by 2. So this circuit is equivalent to C by 2 and C here. So therefore C equivalent will become 3C by 2. And how much is C here? Epsilon naught A divided by D. Epsilon naught A divided by D. Quickly do it. Let me show you one more problem here. With 5 plates. 1, 2, 3, 4, 5. 5 identical plates. I want to make the problem simple. Okay, so 5 identical plates. Here, let me say this is connected to a different terminal, whatever you call. Let me call negative terminal. And plate 3. Suppose this is connected to the positive terminal. Then your 1 and 4 are joined. What will be the capacitance of this system? How to do it? Can you give it a try? Give it a try now. What will happen here? Negative can't help positive. Okay. Now this plate is isolated. This, of course, all these 3 plates are isolated, but this is completely isolated. At least these 2 they are connected. So these 2 together are isolated. This is not isolated. This one is not isolated. They are together isolated, but this plate is completely isolated. So on this side negative, on this side positive. If positive is there, then I can expect here negative. If negative is there, then I can expect here this is negative. So if this is negative on this side, there will have to be positive. If this is positive, they will become negative. That means if this is minus Q, if this charge suppose is minus Q, then this particular charge will become minus Q, then charge here will become twice Q. Okay, so on the positive plate, if this is minus Q, this is going to be plus Q. Okay, if this is minus Q, this is going to be plus Q. If this is plus Q, this is going to be minus Q. And if this is minus Q, this is going to be plus Q. So from the positive terminal, how much charge is entered? Twice Q. So from the negative terminal, how much charge will have to enter? Minus twice Q. So this is exactly the charge distributions, right? So I'm not interested with that now because I have to find equivalent capacitance now. So just I have shown you something in short. Okay, so how many capacitor? Negative, positive, positive, negative. Sorry, negative, positive, negative, positive, positive, negative, positive, negative. Total there are 1, 2, 3, 4 capacitors are there. Okay, so let us see how to find how they are connected now. Are they connected in series or they are connected in parallel? So here you have to work it out. 4 plates. Here you have to work it out. Had the connection been like this, 1, 2, 3, 4, 5. Had a connection been like this, plus, minus, you could have said 1, 2, 3, 4 capacitors are connected in parallel. Why parallel? Because all positive plates are connected to one point, all negative plates are connected to the other point. In this situation, all capacitors are connected in parallel. If I put one more plate and if I join it, 1, 2, 3, 4, 5, all connected in parallel. Okay. If I join one more plate and join here, 1, 2, 3, 4, 5, 6, all connected in parallel. When alternate plates will be connected to one terminal and the other alternate plates will be connected to the other terminal, then how many numbers? They all will be in parallel. Okay, but here we have to figure it out whether this is parallel or in series. So for that, let us start with how to start it. Let us start with capacitor first, second. Let us start with capacitor, second capacitor, or we can start with third capacitor. That means I want to take one terminal. Okay, so let me take capacitor number 2. Capacitor number 2. have just started blindly. For example, I do not know anything. So this is the positive plate. This is a negative plate. Positive plate of 2 is connected to the positive plate of 3. Positive plate of 2 is connected to the positive plate of 3. Negative plate of 2, this one, is connected with the positive plate of 1. Negative plate of 2 is connected with the positive plate of 1. Just keep on doing. You will figure it out. In one attempt you may not get it, but quickly you will make it out. Negative plate of 2 is connected to the positive plate. Negative plate of 2 is connected to the positive plate of 1. And negative plate of 1 is connected to the negative plate of 3. Negative plate of 1 is connected to the negative plate of 3. And positive plate of 4, or negative plate of 1 is connected to the negative plate of 3, and negative plate of 3 and 1, they are connected to the positive plate of 4. Clear? So this side is coming to the positive terminal. Any other plates which are connected to the positive, on positive terminal, only 2 plates are connected, positive plate of 2 and positive plate of 3. Positive of 2 and positive of 3 connected. These 2 are connected to the positive plate of capacitor 4. Okay, negative of 1 and negative of 3 is connected to the positive of 4. Negative of 1, negative of 3 is connected to the positive of 4. And negative of 4 is connected to the negative terminal. Negative of 4 is connected to the negative terminal of the battery. So what we have found? 2 are connected in parallel, then is series. This is what we have seen in the last part. So here C and C, C by 2, C by 2 and C in parallel, equivalent is 3C by 2. Now 3C by 2 and this particular part, we have done it many times. The equivalent of this particular part is how much? 3C by 2. And on this side, that is how much? C. This is C. This is C, C, C by 2, C by 2 and C in parallel, 3C by 2, 3C by 2 and C in series. So how much will become C equivalent? So this one into this one, C1 into C2, C1 into C2 divided by C1 plus C2, 3C by 2 plus C. This will become 5C by 2, okay, 3C into C divided by 2, 2 to cancel, CC cancel, this is 5C, sorry, 3C by 5, which will become 3 by 5, C is how much? Epsilon naught A divided by D. Common potential. This is a very popular topic for NEET point of view, common potential. Okay, let me take a capacitor having capacitance C1 and connect it to a battery of V1 volt. V1 volt. Another capacitor of capacitance C2 and it's connected to a battery of V2 volt. They are fully charged. They are fully charged. Okay. So one capacitor of capacitance C1 is connected to a battery of V1 volt. Another capacitor of capacitance C2 is connected to a battery of V2 volt. So in the first case, how much charge will get deposited? It's Q1. Q1 is what? C1 V1. In the second case, what is the charge deposited? That is Q2. Q2 is what? C2 V2. Once the capacitors are fully charged, these capacitors are now isolated from the batteries. Batteries are removed. क्या किया गया? बैटरी को remove कर दिया गया. Battery is being removed. So how much is the charge here? Q1. C1 is C1. How much is Q2? C2 V2. Now there are two situations. We'll join them now, but in two different ways. In the first case, their like plates are joined together. Their like plates are joined. That means just see this connection. Positive plate, negative plate. This is C1 is going to be connected with the positive. Positive is going to be connected with the positive and negative is going to be connected with the negative. This is C2. I am yet to be connected, so I am keeping a key here, switch. It's not yet connected. So across this one, what is the potential drop? V1. Across this one, what is the potential drop? V2. And we do not know whether V1 and V2 are equal or not. If they are equal, no exchange of charge will take place because charge flows from high potential to low potential. So if the potential of this capacitor and the potential of these capacitors are same, then no charge is going to flow from one capacitor to another capacitor. So in this situation, okay, redistribution of charge will not take place. But if this capacitor potential is V1, this is potential is V2, and they are not same, then charge will start flowing from high potential to low potential. It can flow from here to here, or it can go from here to here. So when charge will get modified, so automatically the potential here no longer will become V1, potential here no longer will become V2. The charge will keep on flowing from one capacitor to another capacitor unless and until in both the capacitors potential does not become equal. Okay, so when I join the switch, here how much is the charge? Q1. Here how much is the charge? Q2. Plus Q1 plus Q2. Plus Q1 plus Q2. Minus Q1 minus Q2. So if I join this switch, charges on the capacitor will get modified, and they will have potential difference across this one, and potential difference across this one will become the same, V. This will be called as a common potential, which we can call potential between A and B. Okay, so between these positive plates and between these negative plates, distribution of charge will take place. And suppose here charges become Q1 dash, and here suppose charges become Q2 dash. If this is Q1 dash, then on this side minus Q1 dash. If this is Q2 dash, then on this side minus Q2 dash. This is the new charge that is going to appear on this particular surfaces. Okay, but these two capacitors were isolated. These two capacitors, they're not having any connection with an external source, external battery, which can supply charge. So that is why between them, what was the charge initially and charge finally will have to be equal to same. For example, here there was 2 coulomb, here there was 5 coulomb. Okay, now charge distribution has taken place. So if this becomes 2 and 5, total was 7. Here if the charge becomes 3, then here charge will have to be 4. So the 3 plus 4, 2 plus 5, both becomes equal to 7. So now we have to find out what is the common potential between A and B. That means what new potential they have achieved. Okay, so from conservation of charge, we get Q1 dash plus Q2 dash is equal to Q1 plus Q2. That means final charges on positive plates is equal to initial charges on the positive plates. So Q1, in this case, what is Q1? C1 into V. What is Q2 dash? Q2 dash is nothing but C2. C2 into V. And Q1 plus Q2. So from here I can take V common. So if I take V common, how much will get? Q1 plus Q2 divided by C1 plus C2. Or Q1 I can write it as Q1. How much is C1 V1? Q2 I can write it as C2 V2 divided by C1 plus C2. This will be the new capacitance between, this will become the new potential, the common potential for both the capacitors. Okay, so this is the first case. Their like plates are joined. What will happen if their unlike plates are joined? Second case is what? Their unlike plates are joined. If unlike plates are joined, that means positive of one will have to be connected with the negative of the second. That means plus Q1 will be connected with minus Q2, or minus Q1 will be connected with plus Q2. What will happen to the common potential? Okay, as long as this switch is open, potential drop across this one is V1, potential drop across this one is V2. Capacitance is C2 only. Here capacitance is C1. Now what will happen as soon as we join it? When you join the switch, the capacitor, the charges will get redistributed. Suppose here charge is Q2 and here Q2, sorry, Q2 I'm taking Q double dash, Q1 double dash, and suppose Q2 double dash charges here. It is not necessary that charges will become positive, okay, but one thing is sure, the final charges will become equal to initial charges, but it's not like that one plate will become negative, positive, the other plate will become negative. Both will have to become negative or both will have to become positive. For example, this is 2 coulomb and this is minus 8 coulomb. So you can understand 2 coulomb minus 8. If you add, how much is that? 6. 2 coulomb and minus 8. How much will become? 6. So total will have to be how much? Minus 2 coulomb and minus 8 coulomb. How much will become? Minus 6. So minus 6 means if you think here minus 2, there will be minus 4. If you think here minus 3, there will be minus 3. If you think here minus 1, there will be minus 5. But one positive, one negative, it cannot be there. Okay. On the other side, Q1 dash, Q1 double dash, Q2 double dash. Now, as a result of the charge will keep on transferring from one capacitor to another capacitor unless and until they do not achieve a common potential. That is potential between A and B. We have to find now common potential. This is called common potential. So from conservation of charge, COC, again Q1 double dash plus Q2 double dash is equal to how much? Q1 plus minus Q2. Q1 is added with what? Minus Q2. So Q1 double dash is what? C1V. Q2 double dash is how much? C2V. So this is how much? Q1 minus Q2. So from here common potential has become Q1 minus Q2 divided by C1 plus C2, or Q1 is nothing but C1V1 minus C2V2 divided by C1 plus C2. This will be the common potential when unlike plates are joined together. We'll continue from here in the next class.